Molar volume. Now before we look at molar volume, we need to have a look at our dear old friend Avogadro. Of course, Avogadro came up with a gas law. And the law was that the volume of gas is directly proportional to the amount of gas in mole. So the more gas you have, the greater the volume the gas will be. This is of course assuming constant temperature and pressure. So we can look at this as V is directly proportional to the number of mole, or V equals Kn, where K is a constant. This can also be written as V1 on N1 equals V2 on N2. The understanding of this ratio is important when we look at molar volume. We know that any minor change in temperature or pressure has a significant effect on the volume of gas, and we can use this relationship to establish how many moles of gas there are. We use these two standards, STP, which is standard temperature and pressure, and SLC, which is standard laboratory conditions. At STP, 1 mole of any gas at 0 degrees Celsius and 101.3 kilopascals has a volume of 22.4 litres. At SLC, which is 25 degrees Celsius, and again the same pressure, 101.3 kilopascals, the volume of gas will increase to 24.5 litres. So you can see the difference between STP and SLC is that STP is 0 degrees Celsius, SLC is 25 degrees Celsius. And as temperature increases, volume also increases. Knowing these two standards here, we can use these to work out the number of mole of gas if we know what volume it is, and I'll show you how. Okay, so at either STP or SLC, the number of moles of gas can be calculated if the volume of gas is known. Using this formula that the number of mole equals the volume of gas over the volume of the molar gas, which will either be at STP or at SLC. V equals volume and V equals molar volume. So at STP, molar volume is 22.4 litres per mole, and at SLC it's 24.5 litres per mole. Okay, here's an example question. How many moles of chlorine gas are present in 48.0 litres of gas at STP? First things we need to do is write down what we know. So we know that volume is 48 litres. Volume at STP is 22.4. 1 mole of any gas at STP will take up a volume of 22.4 litres. We plug them into the formula, N equals V on Vm, so we get 48.0 divided by 22.4, and we get an answer of 2.14 mole. So here's a question for you to try. A sample of pure argon gas was collected at STP and found to occupy 10.0 mil. What must have been the mass of the gas? Now remember, to find the mass, you must first find the number of mole. So have a go at this question, pause the video, and then I'll pop the answer up. So the answer is 0.0179 grams. If you got this right, well done. You don't need to watch any more of this video because I'm just going to run through the work solution. So look at the important parts of the question. We know that we've got a pure argon gas, it's at STP, and it occupies 10.0 mil. So V equals 10 mil, which we change to litres because STP is measured in litres, and you'll find that most of the gas laws are in litres. STP, the molar volume is 22.4, so we can write down that information too. Now we just use our formula, N equals volume over molar volume, which equals 0.01 divided by 22.4, which equals 4.46 by 10 to the negative 4 mole. This is the first part of the question because it's asking you to find the mass. So to find the mass, we need to look at the molar mass of argon, which equals 40. Then we can use M equals N times M, which equals 4.46 times 10 to the negative 4 multiplied by 40, which equals 0.0179 grams.